Does exercise make you lose weight or body fat? Hi, I'm Marcel-Jan. This is Pizza Cutter, by the way. And I've been gathering data on my own health, like weight, body fat, and I've been gathering data like my heart rate during exercise and calories burned. And I'm trying to tease out something about what exercise actually work and what exercises not so much. And a while ago I followed a course on R and RStudio by Kirill Eremenko from Super Data Science on Udemy. And I'm trying to tease out anything interesting with R and RStudio. And I found out it's actually harder than you think. So this is the base material for this analysis. An Excel sheet I started working on somewhere in 2012. First weight and body fat, then calories burned and kilometers cycled, sleep quality, and more and more I've added. Not all very useful, by the way. There's all the columns here in Dutch, but I translated them in English in my RStudio analysis. So let's look in RStudio and see what we can do there. So here we are in RStudio, and we can do a language called R. And it works basically like this. Here's a variable called v. I'm going to put a value in it, 3. And I do it like this, with this sign, the smaller than minus sign. Why not an is sign? I don't know, but it works. And you do Control Enter when you select it or when you stand on it. And below you see, hey, the console says it worked without errors. And upper right you see the environment, and you see, hey, there's a variable called v with a 3 in it. So that works. But of course we want to put all our data in a variable. I really have a problem saying variable. Anyway, for this I need to set a working directory. And this is mine. Bestanden means files in Dutch. It's Dutch. And here I have a new variable, and it's called weight data, and I'm going to put a whole CSV in it with the read.csv file. And I push Control Enter, and there suddenly there it is. There is weight data. I can click on it, and then you get to see what's in it. So this almost looks like the Excel sheet, except with we get here column names that we can refer to, but that's not very useful. It's x.8 and that kind of stuff. So let's give these columns actual good names with this command, call names. So we do that, and now we click on it, and there we are. And oh yes, here on line 2 are the column names. I gave these in Excel, but we're not going to use that. Now, in R, we can get a feel for what kind of data is in these variables. So we do, for example, str, which doesn't mean string, but it means something like statistics, something, and there you get it. So all these columns have a couple of levels in them, and it gives you a feel of what kind of data is in there. We can also do something called summary, which is also nice. There you get more of these columns here. But there's a thing that is not entirely right with our data. Here, for example, the dates, it counts the number of dates that occur the most. And it's weird that August 2nd of 2014 occurs twice, and a couple of other dates as well. I don't want that, but okay. But also it says, okay, yeah, the column weight, yes, the weight 87.2 kilograms occurred 86 times. Like it's just a string that occurred a couple of times. And I don't want that. I want it to be seen as a number where you can do statistics on. So first of all, we're going to set that right with the dates. We have an addDate command, and we're going to tell the RStudio to make this into a date format. And now when you do summary on just the date, you see, hey, there's a minimum and there's a maximum and there's a median and there's a mean. So that's much more statistics-like. Same thing with the date, with the weight data. So it says, oh, you had a couple of empty values there. That's okay, I don't mind. we ignore that and we do a summary of that, and there you see, hey, there's the minimum weight, and that was and there's maximum weight. Fortunately, very long ago. It is mean and it's maximum, and then we do the same for all these other a lot of other columns. There we go, and then we can do a summary, and we get to see that lots more of these values have a minimum and a maximum and a mean and a median and all that kind of good stuff. So now let's see a graph. I'm gonna use a package called ggplot2, and I'm gonna do that activate it like that. It's a bit like in Python's import command. I've already installed ggplot2. I'm not going to show that here how it works, but it's not too hard. And I can make a plot with this. ggplot is the command for this. And here I say, okay, use this data, and from this data I want you to use the x. For the x I want to use the date, and for the y I want to use the weight. And this AES means aesthetics, and you can do all kinds of stuff in there. When you run it, you get to see nothing, as you just saw when I ran it. You only get to see something when you tell it what kind of graph it is, and there it is, calculating, and there we have a graph. So these are my measured weights over the last 6 years, and as you can see, it's a happy story for me because I used to weigh much more. And then I realized actually my motivation to weigh less was because I wanted to be faster in a cycling race. And the way to do that is weigh less. So you need less energy to ride yourself around. And as you can see, that motivation really worked. Much better than somebody nagging at you that you weigh too much. Really motivated me to do this stuff. And we can zoom in. Let's have a look at the last 200 days. That's what I do here. Is sys date minus, so the current date minus 200, and these are the limits, and then you can have a scale x date. All works nice. We also made a line here instead of a point. Oh, by the way, notice that we do this on an existing variable called weight graph. So you can use put graphs in variables and do stuff with it and change stuff and try things out. It's really nice. So what you see here is my weight in the last 200 last 200 days. And what you see is it's not a smooth line. There are all these, it's almost like noise happening. And the funny thing is that that is something I noticed very soon as I started to keep track of my weight, that when you say, oh, I lost a kilogram of weight, that actually could just be noise in this stuff. We can also make a smooth line, add a smooth line in this graph, like this. And then you get more of the trend idea of what's happening here. And we can do the same things with the body fat. And here's something weird is happening. Suddenly my weight and my body fat went from something like 20 to 25. And then it went back. So what was happening here? I can tell you. In the end of 2015, my first set of scales broke. Not for a Homer Simpson kind of incident. It actually just was end of life, sort of. And I bought a new one, with a brand named Inventum. It's a Dutch brand, by the way. And suddenly the body fat percentage went up something like 5%. And I checked the actual body fat percentage at the doctor's office because that's measured every half year for me. And actually the old no brand scales I had was right. And the Inventum was, so the no-name scale, actually the no-name brand scales was right, and the newer Inventum brand scales were wrong. That was wrong. And then I bought a new set of scales, Soonle, German brand, and this one was a more expensive one. But let's have a look when we zoom in on that data, because it's actually funny. This is the Inventum and has a lot of noise. It almost seems like the new brand, the more expensive brand, has less noise. So that's something you would not expect when you buy a set of scales. Actually, when I stand on the scales, when I did that on the old Inventum, every time I got a different value. So I started to average out values by measuring my body fat a couple of times just to get a sort of good value. But you can see it's way going all over the place. And the newer one actually doesn't do that as much. We can also zoom no, at a certain point I just decided to add a correction to this body fat percentage from the Inventum just because the values were too weird. But at a certain point I got fed up with it and bought a new set of scales. So there's that. And there's also the calories burned. And that looks like this. And it doesn't look very useful because you have this white band here around 700, 800 kilocalories. This is the amount of calories I burn when I do spinning, and I do an hour of spinning every week or 2 hours of spinning every week, but it's usually a session of 1 hour, and you get around about the same amount of calories burned. And the peaks here are cycling holidays, for example, or summer holidays when I cycle more and cycle for longer hours. And when you exercise longer, you just burn more calories unless you're really slow. But I tend not to be, I don't want to be really, really slow. Now, that's all nice, but how do these values correlate? Does burning more calories actually mean that I lose more weight on the next day? So here we are. Let's see a correlation between weight and calories burned with a smooth line in it. And you can see, yeah, it could almost be a straight line. The line at the near the 80 kilograms, that's basically, there are just too few points to make a good smooth line that is actually accurate. And this just, it just says nothing. It doesn't help me to make a decision whether I should be burning more calories or not, because it's just a cloud basically. How about, okay, but there's a thing. The weight versus the calories burnt is actually not so useful. So I decided to create a weight delta between one day and the next day, how much weight I lost. So there's the weight delta. Let's see what that looks like. Another basically straight line. This tells you nothing if I should use, I should burn more calories or not. So how about body fat? Well, here we have the body fat just as it is. That's basically point cloud. And let's see body fat delta. And yeah, so if I burn more calories, do I lose more weight? It's a straight line. It's nothing you can do any science on, as if this was any science. So I mean, thinking, okay, maybe I'm approaching this the wrong way. Maybe I should not look at just day-to-day exercise and the effect on weight or body fat. Maybe I should look at the amount per week or a month. Maybe I should aggregate my data. So I'm thinking, yeah, that would be great. And surely something like R that has statistical background, it should be easy to aggregate your data. Actually, I mean, looking at it, and the best thing I could come up with at this moment was to make an extra column called month if I want to aggregate per month. And it looks like this. So all my dates in my CSV file are now, or at least in my variable, are now set to the first day of the month. So if I have a value on 16 July, it's now 1st of July. If I have the 17 July, it's 1st of the month every time. And this means that I can aggregate per date now. So I can make a graph, and in ggplot you can actually do something like stat summary. And here you can say I want a function for the y-axis, and it is the sum. And it says that's for the week, and it should be for the month. And I make a line.
So let's try that, and it looks like something like, and this is just changing the creating a month graph variable, and here I show the graph and it looks like this. Okay, so these are the calories burned per month. Now I want to see the weight per month, so I do that. Yeah, that doesn't work very well. So what I actually would want is weight on one y-axis with its own scale, and the calories burned on the other y-axis with its own set of scales. But R doesn't seem to want that very much, or RStudio doesn't want that very much, because it's easy to misinterpret graphs with multiple y-axis scales. So the best thing I could come up with is, so what I can do is just make this crude calculation. So it adds, you can see it in the scale now and see if there's anything when I burn a lot of calories, if anything is happening in the weight. And that looks like it's actually, that looks like it's happening. So in the month by month basis, when I burn a lot of calories, you see the weight dropping. And when I do very little, you see the weight going up. So that would be something, well, this is far from scientific and I don't like it, but it's the best I could come up with. What I actually would like to have is just my CSV file, data aggregated, month 1, this amount of calories, change in weight, this much. Month 2, this amount of calories, change in weight, this much. But haven't found out how it works yet. I've also did the same graph for body fat, and here we have the same problem. Body fat is way too low to see in the graph, so we just multiply it by 1000 and then you see this. And not something I can really say much about. So that is basically it, how far I got up to now. And I really would like, if anybody knows something how I could do these aggregations, that would really be really cool. Then I can really maybe make some assessment of how much calories do I need to burn per month to stay on the same weight or something. But yeah, up to now, I'm not finished here, but this already, I've been working on this for a month and I couldn't go any further than this. So I'll be back sometime with a new video to show you how this how far I got next time with R. Or maybe I just tried it next time in a different kind of language. Who knows?
So data science is harder than you think. Even with my own data, turns out you really have to do some wrangling to get some meaning out of it. I hope the result wasn't too disappointing. I hope to return to this topic someday. If you have any suggestions how to do that aggregation in R, I would be really interesting. Put a comment under the YouTube video. I'm gonna put the R code that I have now on GitHub, and I put a link in the show notes. And that leaves me to thank you for watching, and until next time.